Next is equilibrium. What is meant by the equilibrium? So first of all, you have to define the equilibrium, and after that there are two states for a body to be in complete equilibrium. We will see it. If I consider here is object and two forces are acting on this object. One is 2 Newton towards right and the other is 2 Newtons towards left. You have to find out the resultant of these forces. What you get? What is the answer of the resultant forces? Of course, it would be equals to 0 Newton because one force is acting towards right and the other force is acting towards left. Both of these have the equal magnitude but opposite direction. They will cancel each other and the total force is equals to 0 Newton. So in this case, equilibrium is a state in which the object remains at rest. Means that object does not move. Here the resultant force is equals to 0. According to second of Newton, F is equals to ma. When the force is equals to 0, of course the acceleration would be 0. It means that when the acceleration is equals to 0, if the object is at rest, it remains at rest. Or if the body is moving, then it will continue to move. So this state is basically called as the equilibrium. Like if the body is at rest, it remains at rest, and if the body is moving, it continues to move. This is equilibrium. I can simply say that in the equilibrium, body maintains its state. So the same thing is given here. Equilibrium is a state in which an object at rest remains at rest, or if it is moving, continues to move. It means that an object in equilibrium maintains its state of rest or motion. There are two conditions of equilibrium. Let's see this. First condition is basically related with the forces, that the total forces acting on body must be equals to 0. If the large number of forces are acting on the body, then you need to find out the sum of these forces. It must be equals to 0 according to the first condition of equilibrium, which I describe here. So this is basically the first condition of equilibrium. After that, you also know about the moment of the force, that is the product of the force and perpendicular distance. So that net moment on the object must be equals to 0. What does this mean? If I suppose there is a ruler and here is pivot. I place here two objects. One is at 2 cm while the other object is at 1 cm. Here the first object is applying a force of 1 Newton while the second object is applying a force of 2 Newton. I make here two boxes to show that the force exerted by this box is larger. Now you have to calculate the moment of both of these forces. Clockwise movement would be equals to anti-clockwise movement according to the law of conservation of moment. So you also have to apply this. At the end you will see that the total moment would be equals to 0. When the total moment is equals to 0, it means that the body is in equilibrium. But here how the moment comes to be 0? If I consider the first object and calculate the moment, here the force is 1 Newton and the object is 2 cm. So it would be 2 Newton centimeter. For the second object, the force is 2 Newton, but it is at a distance of 1 centimeter. So you get 2 Newton centimeter. Both of these are equal. When you find out the sum of both of these moments, one causes the clockwise movement while the other object causes the anti-clockwise movement. So both of these cancel each other and the total movement would be equals to 0. When both of these conditions satisfy that the sum of all the forces acting on the object must be equals to 0 and the net moment on the object must be equals to 0, then the body is in complete equilibrium. If only one condition is satisfied, body is not complete in equilibrium. So I can simply say that for a body to be in complete equilibrium, both of these conditions has to be satisfied. So let's see here. There are two conditions for a body to be in complete equilibrium as given. First is that the sum of all the forces acting on the object must be equals to 0. The sum of all the forces on the object must be 0. The net moment on the object must be equals to 0. Here is the explanation of the equilibrium conditions. In this figure you can see there is object and two forces of magnitude 2 Newton is acting here. One force is acting towards right while the other force is acting towards left. When you find out the sum of both of these forces, it would be 0 because one force is acting in the opposite direction to the first force and both of these have the equal magnitude. So when you find out the total force, it would be equals to 2 Newton minus 2 Newton, which is equals to 0. So here is the first condition of the equilibrium, that the force must be equals to 0. In this figure you can see here two objects are placed on the left side of the pivot while only one object is placed on the other side of the pivot point. So first of all, on the left hand side there is a large force acting, while on the right hand side the small force is acting. These objects on the left hand side are basically at a smaller distance as compared to the object which is on right hand side. When you find out the moment, of course both of these moments would be equals to 0. When both of these moment is equals to 0, one force causes the clockwise movement while the other force causes the anti-clockwise movement. So both of these moments are equal and opposite, means that one is clockwise and the other is anti-clockwise. So they cancel each other and the total movement would be equals to 0, which is given here. The net movement is equals to 0 Newton meter. So here is the explanation for the equilibrium conditions. According to the first condition of equilibrium, the forces should be balanced. What is meant by the balanced forces? It means that all the forces acting on the object in such a way that when you find out the sum of forces, it would be equals to 0 Newton. The forces should be balanced means that the net force is equals to 0. According to the second condition of equilibrium, the sum of all the clockwise movement must be equals to the sum of all anti-clockwise movement. When sum of clockwise movement is equals to the sum of anti-clockwise movement, in this case the net movement would be equals to 0, which is the second condition of equilibrium. If any one of these conditions does not meet, the body is not in equilibrium. For a body to be in complete equilibrium, both of these conditions has to be satisfied. Here is the exam question that appeared in February-March 2018. A wooden plank rests in equilibrium on two rocks on opposite side of the narrow stream. Three forces P, Q and R acting on this plank. So first of all you can see here there are three forces P, Q and R. P and R, both of these are acting in upward direction while the Q is acting in downward direction. How are the sizes of the forces related? Answer A. P plus Q is equals to R. B. P plus R is equals to Q. C. P is equals to Q is equals to R. D. P is equals to Q plus R. This plank is in equilibrium. It means that for that plank to be in equilibrium, the total sum of the forces must be equals to 0. First of all, here we will apply the first condition of equilibrium because only the forces are given. So I consider it's a plank. One force is acting here P, the second force is acting here R, and the third force is acting here Q. So first of all, see here how many forces are acting in upward direction and how many forces are acting in downward direction. The sum of the upward forces would be equals to the downward forces. After that, when you find out the total force, it would be upward forces minus downward forces. So first of all, I write here upward forces are P plus R. It would be equals to Q. So these are the sum of forces in this condition. If I want to see here the equilibrium state, I just write here the net force is equals to upward forces minus downward forces. I just have to apply this concept here. Upward forces are P plus R and the downward force is only Q. So according to this equation, P plus R is equals to Q. So I just put here Q minus Q. It would be equals to 0. So I can simply say that when sum of the force is equals to 0, the body is in equilibrium. That's why the forces are related by P plus R is equals to Q. So this is given in the answer B. Answer B is correct from here. Let's see the answer and explanation. For a body to be in equilibrium, the sum of all the forces acting on it must be 0. This is the condition of equilibrium. It means that the upward forces should be equal and opposite to the downward forces. From above figure, the upward forces are basically the sum of P plus R force, and the downward force is only one, which is Q. You have to equalize here the upward forces and downward forces. Just put here values. The upward forces are P plus R. It would be equals to Q. According to that, answer B is correct. Let's go back and see the answer B. So here you can see P plus R is equals to Q is given in the answer B. That's why answer B is correct from here. Here is the question related to the equilibrium. So let's see this. 4 objects A, B, C and D are shown in the figure. Which object is in complete equilibrium? So there are 4 objects A, B, C and D. Different forces are acting on this object. You have to show that which object is in complete equilibrium. The word complete equilibrium basically shows that you have to find out the sum of the forces as well as the net moment. If both of these gets equal to 0, then that body would be in the complete equilibrium.